So I thought I'd have a go at taking a picture of a very distant object from my backyard. Here's the image that I took with the Unistellar eVscope. It's about half an hour, 3/4 of an hour's exposure. That's a nearby galaxy, NGC 3079, but that's not really what I was after on this particular occasion. I was after this little faint splodged little pair of sources that you can see in the middle of the screen here. And that is QSO0957+561. And it's not actually faint, it's intrinsically incredibly bright. That's because what you're seeing there is material falling into a black hole, and as it falls in, very energetically it collides with other material falling in, it smashes together, it gets very hot, and so you end up producing this intense luminosity that outshines the whole of the galaxy around it. And of course it's a very long way away, so from where we're looking at it, it appears very, very faint. But that's because it's been travelling for about 9 billion years to get to us and spread out through space over that time, so there's very little light to be seen. The other issue is that you can see there are actually two sources here, and if we look at the Hubble Space Telescope picture of this twin quasar, you get to see the reason why, which is as well as the two images of the quasar we can see there, there are a whole load of other galaxies. This is actually a cluster in the foreground, so between us and the quasar, that's acting as a gravitational lens. It's amplifying the light, it's bending it, so actually there are two paths that light can follow, both of which end up arriving in my back garden and falling into my telescope, and so you end up seeing two images of the quasar. This kind of gravitational lens was actually first hypothesized as being a way to detect the masses of clusters of galaxies in the 1930s by Fritz Zwicky, who at the time there weren't any to be seen, but he suggested that it would be a good idea to go out and look for them because they would be a way to actually detect the dark matter which he had suggested was likely to be present in clusters of galaxies. Now that was in the 1930s. It was actually only in the late 1970s that the first of these gravitationally lensed quasars was found. In fact, it's the object that I was taking a picture of for my back garden. One of the things we can learn from gravitational lenses like this is how much mass there is in the cluster, because that's what dictates how the light is bent and how the images are made. And from this, we learn that there's a far more mass in this cluster than just the sum of the galaxies that make up the cluster. So this is one of the strongest pieces of evidence for dark matter in clusters of galaxies. So there you have it, an image of an object billions of light years away, which was produced by material falling into a supermassive black hole, creating an incredibly intense source of light. That light then travelled through space for 9 billion years. Along the way, it encountered a cluster of galaxies, and the gravitational field of that cluster bent and distorted the light such that instead of seeing a single image of the quasar, we end up seeing two images of the quasar, which I was able to record in my little eVscope in a back garden in the middle of Nottingham.